This is the Sahara. Millions of square kilometers of sand, rock. The first problem isn't construction. It isn't technology. And it isn't money. It's water. It is. Across North Africa, the pattern is ancient. Where water flows, agriculture appears. Settlements grow. But what if civilization no longer had to follow the water? What if we could move the water instead? Along the Sahara's northern edge lies an extraordinary resource. Not fresh water, but seawater.
To make the desert productive, engineers would first have to manufacture something the Sahara desperately lacks.
Modern desalination already does this today, but supplying agriculture deep inside the Sahara would require systems vastly larger and far more efficient. Moving water through a desert required enormous amounts of energy. Fortunately, the Sahara receives something else in extraordinary abundance: sunlight. Desalination creates the water. Energy moves it. Together, they could create something the desert has never had. The next challenge is distance. The farms don't exist on the coast. The water has to travel hundreds, perhaps thousands. Before water can cross the desert, infrastructure has to cross it first. Roads, power. The Sahara doesn't make construction easy. Summer temperatures can push machinery, electronics, and people toward their limits. Then there is dust. It enters filters, covers solar panels, wears mechanical surfaces, and finds evidence. And the Sahara isn't simply sand. The route crosses rock, gravel, valleys, elevation changes. Water doesn't simply travel hundreds of kilometers because we want it to. Every change in elevation. In the desert, even stored water is vulnerable. Expose enough of it to heat and dry air, and the atmosphere begins taking it back. Hundreds of kilometers from the sea, the water finally reaches its first destination. Not a farm, only. After years of construction, after thousands of kilometers of infrastructure, the desert receives something. But water alone doesn't create farmland. Desert soils can lack organic matter. Irrigation can concentrate salts. And for the first time, a new line appears across the Sahara. Not a river created by geology. In a place this dry, agriculture cannot treat water as an unlimited resource. Every leader has to do as much work as possible. Traditional irrigation asks a simple question: how much water does a field need? A desert farm asks something more precise: how much does this plant need right now? The farms themselves may require fewer human hands. Machines can inspect, weed, harvest, monitor, but the ancients. Some crops may never need to experience the Sahara directly. Inside controlled environments, heat can be reduced, water captions. The sunlight that threatens crops can also protect them. Placed carefully, solar structures provide partial shade, and the water cannot be used only once. In a desert civilization, wastewater isn't simply something to remove. It becomes a resource to recover. In most cities, water moves through a system. Here, it moves through a loop: used, collected, cleaned, and used again. But every liter of irrigation water carries another invisible passenger: minerals. If water evaporates and salt, and even after the farms begin growing, the desert doesn't disappear. Heat remains, dust remains, wind remains.
One farm becomes a district. One district becomes a hub. Food is grown.
The first successful hub changes the question. It is no longer, can agriculture survive here? The Nile was created by geology. This system would be created by engineering. A river without a natural riverbed. Water makes agriculture possible, but civilization requires movement. Food travels out, materials travel. Once food, water, energy, and transportation arrive, people can follow. But a city in the Sahara cannot simply copy a city built somewhere else. In extreme heat, architecture becomes part of the survival system. Shade reduces solar gain, insulation. Here, losing water means importing more from hundreds of kilometers away. So every leak matters. Every drain matters. At night, the desert changes. The heat retreats. Maintenance accelerates. Entry cells. A settlement built for workers becomes a town.
The town becomes a city, and suddenly the water corridor is no longer supporting from the ground. This transformation looks enormous. Thousands of farms, new towns, entire cities. But before we imagine changing the desert, we have to remember something. The Sahara is not empty. Fissures. Life here has spent thousands of generations adapting to scarcity, to heat, to dryness. And the Sahara doesn't influence only the Sahara. Its dust can travel across seas and oceans, connecting this regions. Change enough land, and you may begin changing more than agriculture. Surface temperature, moisture, dust. So before another corridor is built, the future may be tested millions of times inside a computer. Engineering asks what we can build. Ecology asks where we should stop. The hardest infrastructure decision may sometimes be not building Styxes. Desalination doesn't make salt disappear. It separates fresh water from a more concentrated stream. Some of that stream may contain materials worth recovering. But recovery does not make every problem disappear at enormous scale.
A green field in the Sahara may look simple, but behind every hectare there is water treatment.
By 2100, we may have the technology to bring water deeper into the desert.
Suppose we decide the answer is yes. Not everywhere, not at any cost, but carefully, one corridor at a time.
The shortest route may be cheaper, but the future may demand a different definition of efficiency, not simply the route.
If the first corridor proves sustainable, another could follow. Then another, not a green Sahara.
Perhaps this is what a transformed Sahara actually looks like. Not a forest, not an endless.
Then something changes that engineering cannot measure in kilometers of pipeline.
The purpose of these farms isn't to make the desert look green. It's to produce something useful. Food.
Water may create the green corridor, but energy keeps it alive. And once the electrical infrastructure exists, where reliable energy, transportation, and water meet, industry can follow. The corridor begins producing more than crops. Mega projects are often remembered for the moment they're completed, but a system like this is never really finished.
50 years after the first water entered the desert, the experiment has become infrastructure. Children born. The year is 2100. What began as a water project decades earlier has been. The most extraordinary thing about this future may be how ordinary it eventually feels.
A desert city is only as alive as the infrastructure beneath it. Water, power, cooling, communication.
A liter of water begins at the sea. It may travel hundreds of kilometers, enter a home. The desert never stops being hostile because the sun goes down. And the infrastructure cannot stop either.
Eventually something fails. It always does. The question isn't whether failure can be eliminated. It can't. The question is whether one failure becomes a crisis. Resilience is not a system that never breaks. It is a system designed to keep functioning while something is broken. Reasons provisions. But there is a harder question. What happens if the water doesn't return in hours? What if the interruption lasts days? The answer is stored here. Not in one reservoir, but many, distributed across the corridor.
Building here is not a one-time achievement. Every kilometer of pipeline becomes a responsibility.
By 2100, the most valuable thing created here may not be farmland. It may be knowledge, how to move water, how to reuse it. Technology developed for one desert doesn't remain there. Pumps improve, membranes, irrigation improves. And these lessons may matter for another reason. The future will not become cooler simply because our technology There is no single machine that makes this possible. Energy creates water. Water supports food. Food supports cities. And there is one variable that could change everything. Energy. If clean electricity becomes cheaper, But cheap energy does not make water free. Equipment still wears, pipelines still require maintenance, salt still has to be managed, soil still has to be managed. A new city creates another temptation: growth. But in the desert, population cannot expand faster than the systems.
And beyond the corridors, the Sahara remains what it has always been: vast, dry, wild. The difference between these two landscapes is not water alone, it is energy, engineering, maintenance.
But by the end of this century, that relationship may begin to change. We may begin bringing water to where we decide civilization can exist.
Moving the river sounds simple until you see the machine required to do it. Thousands of kilometers. One drop is almost nothing. One plant requires more, a field requires more, a city of farms requires.
And this is where the dream meets its limit. Not every part of the Sahara should become farmland. Not every part. Perhaps the greatest success would not be turning the desert green. Perhaps it would be learning where green. The future does not have to choose between these landscapes. Agriculture here, wilderness there, technology on one side, protection on the other.
Desalination, energy, pumps, pipelines, robots, railways, recycling, agriculture.
But civilization was never built by technology alone. Behind every machine, there were people choosing what to build and what kind of future it should create. From space, the transformation almost disappears. The Sahara remains enormous, ancient, unmistakable. The question isn't whether technology will change the places we live. It already has. The question is how far that transformation will go. For thousands of years, we built civilization where nature placed the water, along rivers. If this future ever arrive, it will not arrive in a single year. By then, many of the people who built the first systems will be gone, but the machines they created and the responsibilities they accepted will remain. Their children may grow up with a different understanding of the desert, not as empty land waiting to be transformed, but as a place where engineering, perhaps the most advanced city of 2100, will not be the city that grows forever. It may be the city that knows how much water it has and where it should stop. The question is not whether we leave a footprint. It is how large a footprint we choose to leave. And perhaps none of this happens. Perhaps the great pipelines are never built. Perhaps the desert remains largely untouched. Zips. The future is often imagined as something that arrives, but cities do not simply arrive. Every transformation begins with something small. A drop of water, a decision, a machine. Long before our cities, the Sahara was here.
What will we build next? Without a river? In the driest place on Earth? That is where we go next.